I've been a good boy. It works. Right. So like before, we are going to take, okay, so some mention about moment now. Okay. So this is so far the easy part. Okay. So once you have everything right, okay, some mention about forces in the n direction is equal to m ag, and then we're going to take n. Okay. Now I put the g over there because we're going to do, okay, let me put a summation also. Okay. Because later on we have to do the sphere and the what? And the rod. Okay. So from here, we know that we have ON. Okay, ON is positive. And from here, we have minus 98.1 cos 45. And then we have a minus 147.15 cos 45. So all this, there's no more forces in the normal direction. Okay. Then we go to the kinetics. So we know that the first one is a plus. And then we are looking at the rod. The rod is 10 kilograms multiplied by 2.7. So this over here is for the rod. And because the direction is pointing to the center of gravity, or to point O, not center of gravity, I do apologize. And this is 15 multiplied by 6.3. So to tidy things up, so ON is equal to 98.1 times by cos 45 is equal to 69.367 plus by 147.15 times by cos 45, 104.051, and plus by 27, 15 times 6.3 plus by 94.5. So ON is equal to 69.367 plus 104.0. 294.918. Okay. You can round it up to 295. I have no problem with that. Okay. So the next one, we look at the forces in the tangential direction. Right. So you have minus OT plus by 98.1 sine 45. And then plus by 147.15 sine 45. Any more forces we have to deal with? The answer is no. And then the next one is 10 multiplied by 0.3 alpha plus by 15 multiplied by 0.7 alpha. sphere, and rod. Okay. So when you tidy things up, okay, I'm going to bring OT to the other side. It's positive, so this will be equal to 69 point plus by 104.051. And then this one will be minus by 10 times 0.3 plus by 15 times 0.7 minus 13.5 alpha. Okay. So this will be equal to 69.367 plus 104.051, 173.418, and then minus 13.5 alpha. Okay. So we don't know what is alpha yet. Okay, I have not a clue what is alpha yet. So alpha unknown. So that's where we form our third equation. We are going to go for anything that is going, I'm going to, for the fun of it, try this out. Okay, anything that's clockwise is positive. Summation about moment. I'm going to take at point O, okay, and then summation about moment, point O, kinetic. Okay, I'm going to just pick clockwise to become positive for no reason. Okay, because later on, if I were to put anti-clockwise, I think both sides will what? Cancel out. Okay, so we go from there. So I would like to copy this diagram again. See, can I paste? Right. So we're going to take moment. So we're going to take moment at point O. So point O is this position over here that I'm circling in green. Okay. So what we have, the 50. Okay. So let me anything that's positive. Okay. So the 50 is positive. So the 98.1 sine 45 is going to induce a moment. Okay. So you have 98.1 sine 45 multiplied by a distance of 0.3. Then plus by 147.15 sine 45 again. Then multiply by distance of 0.7. Now the next function, okay, will be a positive, and we have to summation moment about 0 at point K. Now this is where things can get a bit messy, but not necessarily impossible. Okay. So now we have to determine our summation about, or our summation about MOK. And in fact, if we were to look at the formula that MO, moment about point K, is equal to I naught alpha. So we are going to find the mass moment of area about point O. Okay. And it's not difficult. Okay, it's not difficult. I'm serious. It's not difficult. Mass moment of inertia. I got confused. I thought I was still teaching 2PO4 on Friday. I knew it. You guys did not pick up my offer for revision for 2P. I was so upset. Only 5 students came. And I believe we have a blast of a time. Okay, so now let's look at, so I will provide you with these diagrams. There are 2 diagrams that we have to consider here. One is a sphere. Okay, so I'll put the formula here. You guys will be good to go. Okay. And then the other one is for the slender rod. So I like to do the slender rod first because it's pretty interesting. Okay, let's do the slender rod first. Okay. So let's consider the slender rod. There are 2 ways that you could do this for slender rod. So we want to find the mass moment of inertia at point O, and the general formula is mg plus by md squared. Okay. So I'm going to use, I'm going to use Ixx or Iyy is 1 over 12 ml squared plus by md squared. So this will be equal to 1 over 12. The rod is 10 kilogram, 0.6 squared, plus by 10, the D is equal to what? 0.3. So this will come out to be 1 over 12 times 10 times 0.6 times 0.6 plus 10 times 0.3 times 0.3, 1.2 kilogram meter squared. Or you can use this formula over here. Ix prime, which is equal to what? 1 over 3 ml squared. So 1/3 multiplied by the mass of 10 multiplied by the length of 0.6 squared. So 1 over 3 times 10 times 0.6 times 0.6 is also equal to 1.2 kilogram meter squared. Okay. So either one you use, I'm fine with it. Okay. So if you use the center, you need to do the shift, the para-axis theorem. If you use this point, you don't need to shift. Are we clear? Okay. I'll stop here. I'll see you guys tomorrow. Yes. Thank you.